Hey Dr. Lane, so I'm doing a reassessment for Chapter 6. I chose to do a problem out of the back of the book, number 94, and it reads, you throw a ball of mass 1.2 kilograms straight up. You observe that it takes 3.1 seconds to go up and down, returning to your hand. Assuming that we neglect air resistance, the time it takes to go up to the top is half the total time, 1.55 seconds. Note that at the top the momentum is momentarily zero, as it changes from heading upward to heading downward. So in A, they're asking us to use the momentum principle to determine the speed that the ball had just after it left your hand. So I did the problem here and I wrote everything that they gave to us. So we're solving for velocity, the speed, using the momentum principle. So we know that the momentum equals force times time. So force is going to be equals to mass times acceleration. We know our mass is 1.2 kilograms and acceleration is going to be 9.8 meters per second squared, gravity, going down. So solving that, we found the force to be 11.76 newtons. Now we can plug this back into our equation and get momentum net equals the force times time, which was seconds, which they gave to us earlier. Yeah, and that's going to give us 18.23 newtons times seconds, or 18.23 kilograms times meters per second. Now you plug it back into your momentum initial formula, which is mass times velocity. So we know what our momentum is because we just calculated it up here, and we know what our mass is. So you divide your momentum by your mass, and you're going to get your velocity, which is going to be 15.19 meters per second. So that's our velocity. Now in B, it asks us to find, using the energy principle, to determine the maximum height above your hand reached by the ball. So we know that our energy principle is going to equal change in kinetic energy equals change in potential energy. So that's going to be, once you rearrange it, Kf final plus potential energy final equals to kinetic energy initial plus potential energy initial. So we plug in what we know. Well, first I wrote down the exact equation for this formula, which is 1/2 times mass Vf squared plus mass times gravity times height, and the same thing on the other side, which is the initial. Now when I plug in 1.2 kilograms times 0 meters per second squared, that's because final, when it returns back to your hand, it's not going to be moving, so it's going to be 0. So once you do that, that can cancel out and it's going to be 0. Plus 1.2 kilograms times your gravity, which is 9.8 meters per second squared, times height, which you don't know, that's what we're looking for, equals to 0.5 times 1.2 kilograms times 15.19 meters per second squared. That's what the velocity we found earlier to be, plus 1.2 kilograms times 9.8 per second squared times 0, because when it's in your hand it's not going anywhere, it's 0. That was the initial potential energy, so that cancels out. So your final kinetic energy and your initial potential energy are going to cancel out. So once we rearrange the problem, we can actually solve for height. So it's going to be 1/2 times 1.2 kilograms times velocity initial squared over mass times gravity. So your masses cancel out, and once you do all your work, you're going to get 11.77 meters. So those are the answers, and that's all I got. Thank you.